Hey, Wizards. For the final episode of Elixir Wizards Season 11, branching out from Elixir, we're featuring a recent discussion from the Software Unscripted podcast. In this conversation, José Valim, creator of Elixir, interviews Richard Feldman, creator of the Roc programming language. They compare notes on the process and share anecdotes from their experiences, guiding the evolution of Elixir and Roc. The discussion provides an insightful look at the experimentation and learning involved in crafting new languages. We hope you enjoy this discussion, and we'll be back later this year for the next season of Elixir Wizards.
You are listening to Software Unscripted. I am your host for today, José Valim. I'm joined by Richard Feldman, creator of the Roc programming language and the usual host of Software Unscripted. Let's go. Richard, thanks for joining me.
Hey, thanks for coming up with the idea of doing this. This should be fun.
Yeah, so for a little bit of context, I've been on the show twice, and I'm a frequent listener of the show. And then sometimes Richard mentions the Roc programming language. But since he's the interviewer, we don't get to hear a lot about Roc, and I'm always curious to learn more. So we are swapping roles for one day.
Right.
And to get us started. So how did Roc get started? How was the idea? How was your process behind it?
Yeah, so the backstory is I love Elm. This is maybe not a shock to a lot of listeners. I wrote Elm in Action, the book for Manning Publications. I did a bunch of workshops, made a bunch of libraries and teaching material and so forth. But I kept finding other use cases that I wanted to have that sort of Elm-like experience besides front-end UI development, which is kind of what Elm specializes on. And so one thing led to another, and I was like, okay, I would love to have this Elm-like experience in other domains. So like web servers is kind of the obvious one, command line applications, native desktop GUIs, but also there was kind of this long tail of use cases like text editor integrations, where it's always like, oh, you can use Lua or JavaScript or Vim script, and like, I really want an Elm-like language for this, or database extensions, or Arduino, like, robotics, that type of stuff. And it basically kind of came to a point where I was like, there's a combination of wanting an Elm-like experience in the long tail of domains, and also my having a bunch of ideas for things that for one reason or other just didn't make sense for Elm. And I was like, all right, I finished the book. I've got like more free time. This is before I had a kid. And I'm looking for like a big juicy project that I can sort of work on for like a really, really long time. And one thing led to another. I said, I'm going to do it. Let's make a language to solve these problems that I'm having for myself, and also have a really long-term project that I can sort of sink my teeth into for a long time.
Was it a prototype at the beginning where you just wanted to bounce ideas around, or you knew like when you went straight into it, you already had like kind of a good vision and idea of what you wanted it to be, exactly because it came from this experience of wanting to run Elm in all those different places?
So I would say that there were a number of things that I would think of as experiments that I wanted to do. So something that I learned from Evan is a good way to think about programming languages is that every programming language is in some sense an experiment. It's like you have a hypothesis that something's going to be good or like a good experience or going to go well, but you don't really know until you try it out and people use the language and then you find out. And I see you nodding, like I guess this is your experience with Elixir too. But so I had these ideas about like, I think this would be really cool in an Elm-like language, but I don't know. And in some cases it was like, this is not something that's reasonable to try out with Elm. So a really good example of this is we have this feature, which is one of the successful experiments called tag unions. And it's basically a way of having some types, aka algebraic data types, aka enums and Rust, or discriminated unions and F#. It's got all these different names, custom types in Elm. And the idea is to make them anonymous. So in OCaml, they have this feature and it's called polymorphic variants, but they're not used very often. Most often they use in OCaml the traditional sort of sum type where you have to declare the type up front, and the polymorphic variants have a sort of a separate syntax and are only used for certain special purpose things. So the idea was, what if we make the anonymous one the first class, like only way to do it? And that has some really nice benefits for error handling. And OCaml had sort of talked about some cautions about some of the downsides of doing it this way. And my feeling was that if we did it in a certain way, that those downsides would not really manifest. And so far, they basically haven't. It's just worked out really well. But that's the type of thing where if you tried to do that to Elm retroactively, that would be this massive breaking change. It's just not worth it for an experiment like that. Like, what if it didn't go well? But if you're starting from scratch and you're just like, nobody's using this language in production, you can try out things like that. And so as far as vision goes, I had an idea of the problems I wanted the language to solve and how I wanted it to solve them. But when you get down to these specific design elements like that, it was just a lot of experiments. It was like, I think this might be nice, but let's find out.
And there's always the difference between so if you go back and add it to Elm is going to have two things, right? And that's always different than, hey, just having one thing, right? And what leads to that. Yeah, I think there's a lot I want to unpack from that answer.
Let's unpack.
Yeah, but I want to go back just a little bit because maybe some people is going to be joining the show and they don't know anything about Roc. So you mentioned Elm. So people have used Elm, and you mentioned types. So people may be expecting, something functional, statically typed.
Okay, yeah.
So how would you describe Roc? Like maybe the elevator pitch.
Sure. So the tagline for Roc is it's a fast, friendly, functional language. So fast, both in terms of fast runtime performance. So we have a really strong value on trying to have go really fast. And we look at C++ and Rust, and we're usually comparing ourselves to them and seeing okay, we're slower than the fastest that it could be, but hopefully not by much. And we want to minimize that gap as much as possible while still being an automatic memory managed language that has memory safety. Also fast in terms of compile time. So it's also really important to me that we have really fast build times. And that is with full type checking and monomorphization, which helps with making things run fast at runtime, but has downsides in terms of build times. Friendly in terms of user friendliness. So it's really important that we have really nice error messages. That's definitely something that we get from Elm and are trying to sort of live up to Elm's sort of gold standard there of really nice, helpful error messages. And then functional because it's a purely functional programming language. So that means that semantically, everything is immutable and constant. But in practice, what that actually means is that as far as you can tell, things are not observably mutable in the language. However, behind the scenes, we do opportunistic mutation as a performance optimization, such that if it's not observable and you will not be able to tell a difference in the semantics of your program, we can update things in place and therefore use different data structures than most functional languages use and get some performance benefits from that. That's another sort of hypothesis and experiment, which so far has been working out. But again, I don't want to assume that it's going to be great across the board until we've really gotten sort of more people using Roc.
Fantastic. Yeah. So this leads great into one of the questions I wanted to unpack, which is, you had some experiments running. We talked about tagged unions, we talked about opportunistic mutation, we'll go back to those. But is there any experiment that has already failed and they're like, ouch, this is a bad idea. Let's roll back and try something else?
Yeah, so one that came up really early on, and it's something that might come up in the future, but we tried making ways to combine records a little bit more flexible than it was in Elm. So records are kind of like, if you imagine objects in JavaScript, but you just take away basically all the features. You're just all we have is name and then value, key value pairs sort of, that you can't iterate over them. You can't add them on the fly. You can't turn them into strings. It's really, really stripped down, just basically I want to say I have this key and this value, and then that's it. So the idea was, let's see if we can introduce some features around letting you combine these things on the fly, which Elm actually used to have more ways than it did, but ended up sort of subtracting them for various reasons that I didn't think necessarily applied to Roc. And so we tried this out and kind of used some JavaScript-looking syntax for it, where you could say, I have one record and then I want to combine it with another record. We're just going to kind of union all the fields together. Some things like that. And basically the first implementation of that we tried in the type checker ran into some implementation challenges. This is back when it was just me and Volkert de Vries working on the type checker. And we were pairing on this, implementing this at some point, and we kind of got stuck and realized that this was not going to be as simple a change as we thought it was going to be. So all right, you know what? Let's just roll this back and just bail out and just do exactly what Elm does with these, because we know that works and it'll be fine. We could still revisit that in the future and sort of think it through more and maybe constrain the design space a little bit more, and maybe we can end up with something like that. But that was the first example I can remember of something where we tried it and it just didn't work out. A more recent example, which is in the process of not working out and we're going to remove it from the language, is the number type nat. That's the name we chose for it. In most languages, like Rust, for example, calls it usize, I believe. So like C calls it size underscore T. I don't remember what Go calls it, but at any rate, basically it's a type that is quite useful for collection lengths because the characteristic that it has is on 64-bit systems, it's a 64-bit integer, and on 32-bit systems, it's a 32-bit integer, which, because of the way memory addresses work, is kind of the maximum that you want to have for like collections on those sizes. Because if you have a 64-bit length on a 32-bit system, you're just going to be wasting half of that memory because you just can't really have something longer than 32 bits worth of length anyway, because the memory addresses don't go that high. So that was the original idea behind having it in the language. However, it's turned out to have a lot of edge cases that I hadn't anticipated, especially around compiling to multiple targets. So you get certain scenarios that didn't really anticipate around, for example, like serialization. And now you're like, okay, well, my serialization code is going to work one way on this machine, but it's actually going to work a little bit differently on this other machine, just depending on which target I'm building for. And for a language like Roc that's kind of high level, and especially one that's sort of purely functional, that's a really undesirable property. I would ideally like to say, look, if I build my application, I don't care if I'm targeting WebAssembly, which is 32-bit, or I'm targeting 64-bit desktop CPU. I want my application to do the same thing on all those targets. I want it to run the same way, even things down to like, I want the hashes to be the same. And NAT, just because it was different, ended up having this sort of cascading effect where it would cause a lot of things to be different. Like the same function produces different answers just depending on what target you're building for. So what we realized after sort of talking this through is that what we can do is we can actually have it be so that behind the scenes, we use 32 bits of storage on 32-bit targets, but we just convert that to a 64-bit integer whenever you do something like ask for the length. So the new plan is to basically replace NAT with just U64, so unsigned 64-bit integer, everywhere in the API, but actually just behind the scenes use the 32-bit storage so we're not wasting memory. There's one other trade-off there, which is hypothetically, we could get to a world in which 128-bit systems are a thing. That's not a given. It's not a guarantee that we would actually get to that point because right now, 64-bit systems only use 48-bit addressing. So we actually have quite a ways. That's because of the hardware limitations. Whatever, that's a tangent. Point is, it's not necessarily safe to assume that at some point there will be 128-bit systems because it could be that by the time we get to the point where something like that would make sense, the hardware might look so different that we're not even talking about like how many bits your addresses are. We're just like, the hardware just looks fundamentally different. And now we're not talking about the same things anymore. And who knows what that world looks like. That's possible. Another possibility is that we get to that world and we're like, you know what? It's fine to just use 64 bits for all these things. Java, for example, still has 32-bit lengths for all of their collections because that was kind of the norm back then. And that means that you, for example, can't have an individual array in Java that's like more than a couple gigabytes. But that's something that you have to work around if you're working with really, really large contiguous buffers like video file editing or something like that. But again, it doesn't come up that often. And the same would be astronomically more true of 64-bit collection lengths. So there's good reason to believe that this would simplify things, make the language work better cross targets, reduce the learning curve a little also because it's one less concept you have to learn, especially one that's kind of always been a weird edge case, and really not have any foreseeable significant negative consequences over the long term.
So I have a follow-up question.
Sure.
Do you have an integer type then? Or do you have like signed 8, signed 32?
Yeah, so we have several different integer types, which actually comes up sometimes as a downside of the language. So the upside of this is performance. It means you can pick, I want to use this precise integer type and I'm not going to be wasting any memory, whatever. That's great. And that's, of course, the reason we have that. The downside is that, so advent of code is happening right now as we're recording this. And something that I have seen people run into is getting integer overflow because what they're doing is they're going through a string 1 byte at a time and they're doing, I'm actually not doing the advent of code problem, so I'm not sure exactly what it is that they're doing with it. But so they have 8-bit integers, that's what you got in a byte, and they're doing things like adding them up or doing multiplication on them or something like that. And what they're seeing is they get overflow because you only get to go up to 255 if you're in a byte, and otherwise it overflows. And if you don't use any explicit conversions to sort of upgrade that to a bigger type before you do your multiplication or before you add them all up, then what happens is an overflow. Now, it's an easy fix, but if we just had one integer type, like let's say 64-bit integers or something like that, on the one hand, that would mean that we would have bytes stored less compactly, which is unfortunate in terms of memory usage and performance, but it would mean that people wouldn't run into that.
Yeah, just a parenthesis, advent of code has been great for Elixir as well. Just having new people try it out and see where they run into, and they're like, oh, I can improve the error message here, or I can provide something here and there to improve the user experience. So it's really nice to see that that's also the case with Roc.
Oh, yeah. We've seen a huge amount of people doing advent of code. I mean, I say huge, it's like dozens, literally dozens.
Yeah.
Like not like a stadium full of people, but relative to past years, I mean, now that we launched the new website and we got a bunch of new visitors from Hacker News and a bunch of new visibility and stuff, it's been actually like really actively difficult to keep up with. We use Zulip for our chat, and just the number of people posting and asking questions and sharing solutions and stuff, it's overwhelming, but in a really cool, exciting way.
That's great to hear. Yeah. And going back to the integer, so if you have, well, you do have a plus operator.
Yes.
So I assume like the type signature for that thing, does it define the relationship between all the types? How would that go? Is it like, oh, if I receive signed 8, return signed 8, and then you have to define all the possible inputs? Or is it something slightly different?
That's a great question. So the way that plus works is, so all the operators in Roc desugar to something else. So there is no like plus is its own thing. It's like plus is syntax sugar for calling the num.add function. So num.add in the docs takes two numbers and then returns a number. And both of the input numbers have to have the same type. So you can give it two U8s if you want, but you can't give it like a U8 or U16 or you get a type mismatch. And then it returns whatever the type is of the two arguments that you gave it. It has to be a number type, but it can be any number type you want. We do have some that are more specific than that. So we do have like an integer concept in Roc, but it's not a concrete type. It's like, for example, you have an integer division. It's like num.divint, which says, give me two integers and I will give you back an integer. Actually, I think we named it more specifically than that. It used to be divint, but I think now it's divtrunc to tell you that it's like truncating, just so it's like right there in the name to tell you like, hey, your stuff's going to get truncated. It's not going to give you a decimal back. So yeah, that's generally how arithmetic operators work.
And you mentioned there is an integer type. Would that be like a tagged union of all the integers, or is that something else? Like, I'm trying to build on the concepts that you've gave to us so far.
So number types in Roc are a bit unusual. It's a technique that I use in order to make things work intuitively, but it's a little bit weird in that I haven't seen it be useful anywhere else in the language. I'm sure someone will look for it, but I don't know that it's a given that it is a good idea to use it anywhere else. But essentially the way that it works is it's using phantom types. So a phantom type, for those who are not familiar, is basically where you have a part of a type that has some information in the type signature, but that information does not appear anywhere at runtime. It's just there at compile time. So phantom types are useful for a number of things. That's not what's weird about it. What's weird about it is that we're specifically using sort of a phantom type to make this nested set of type aliases. So technically speaking, we have the num type, which is the sort of the base of all of these. And then we have this nested tag union thing going on for the different sort of classifications of numbers. So the exact type of, let's say we've been talking about U8, so that's an unsigned 8-bit integer. The exact type of that is num, and then num has a type parameter, and that type parameter is integer. And then that also has a type, like that integer type also has a type parameter, which is unsigned 8. So if you unpack that, you have num, and then inside that is integer, and then inside that is unsigned 8. So the type alias for that whole type I just said is U8, which is unsigned 8-bit integer. So in practice, you always use U8. You never write out the whole num integer unsigned 8 thing. But because it's structurally that way, we can also have a type alias called int. And so the int type alias has a type parameter. And so it's basically int, and its type parameter is alias to num with integer of whatever that type parameter is. So now it works for num integer unsigned 8, num integer unsigned 32, num integer signed 64, whatever, all the different integer types. But it doesn't work for like the fractional types, which have their own set of type aliases. So that's the sort of elaborate technique, is it's this like nested phantom types with type aliases. I don't want to call it a pattern because it's like we only do that for numbers. But yeah, it's a very sort of niche use of the language features. And basically the motivation for doing that was that I didn't want to make a separate language feature just for number arithmetic. But of course, people expect plus to work a certain way, which is totally reasonable. They expect division to work a certain way. And I know, like from a language design philosophy perspective, as I understand it, this was actually the original reason that Haskell added type classes, was that they wanted to be able to have plus work on multiple different distinct number types, which is also totally a way you can do it. Without going into a lot of details, there are reasons why I didn't end up using Roc's ability system for that, even though that is another way we could have gone with it. But basically, it's something where the design goal is let's make numbers feel intuitive and let's not introduce a new language feature just for numbers to do it. Let's find a way to do that with the primitives that we already have. And this was one of the ways, it seemed like the nicest way to make that work out.
I like that a lot. I definitely learned something. If somebody had asked me, I would go with like type class abilities kind of solution for doing it.
Yeah.
I have just one last question, I believe, on this topic.
Sure.
And then we move to something else. Could I say then, for example, that a function receives 2 integers, but not really caring if it's U8? Okay, we are nodding.
Totally.
Yes.
Yeah,
okay.
yeah.
Perfect. Yeah, no, that sounds really interesting. And the composability you get with that. Continue talking a little bit more about types. Please correct me if I'm wrong. I assume that you have a more expressive type system than Elm, for example, based on your description. Maybe not. So it can be an answer. And then the question that I'm really looking is because depending on the language goals, right? When we are thinking about type system, well, we want to have a fast compiler, right? You want to do this, you want to be able to optimize. That implies different things, or like friendliness, right? That implies different trade-offs at the type system level, right? Are you going to have inference? Are you not going to have inference? Maybe some type features that you want to have, but it's not possible because it would be slow. So how does the language goals have affected the design and the choice of the type system?
Gotcha. Okay. So let's define our terms because different people mean different things when they say expressive. So I'm going to use expressive in the term that I learned from Evan, actually, who created Elm, which is essentially that expressive power refers to like it's possible to express a certain thing. So not expressive in the sense of like, I like the way that it lets me express myself, but rather like it's an objective measure of like, it is possible to express this in language A, but not in language B. So there are some ways by that definition that Elm is more expressive than Roc or Elm's type system. And then also the reverse is also true. So tag unions are one way where in some sense, Elm's type system is more expressive than Roc's, and in some sense, Roc's is more expressive than Elm's. So the way in which Roc's is more expressive than Elm's is that tag unions in Roc, you can combine them. You can sort of like union them together on the fly. And this is why they're really nice for error handling. So the classic example of this is, or the simplest example, I should say. Let's say I have a conditional, like an if-else. In the one branch of the conditional, I'm returning the tag foo, and in the other branch, I'm returning the tag bar. And then just putting that into the REPL, for example, you will get back an inferred type of that as the union of foo and bar. So it just figures out on the fly, well, this branch can return foo, this other branch can return bar. So the whole expression is like foo or bar, essentially. That's kind of the main motivation behind tag unions, is being able to do stuff like that. And for error handling, it's really nice because what you get is like, well, in this branch, it could have this error, and this branch could have this error, and this branch could have this error. And now at the end, you end up with a union of all those different possible things that can go wrong. And it's all nice and exhaustive checks and stuff like that. Originally, when we developed this feature, or the first implementation of it, was, I think you could say, strictly more expressive than what Elm has. However, it had some ergonomics problems. And basically, whenever you would make a tag, there would be a type variable that was visible in that type. So if you put like foo into the REPL, it would say, the type of this is foo with a type variable. And it was a really common beginner question, like, why is there a type variable there? I just made this concrete thing. I said, it's just foo. Why is there a type variable on it? And also that type variable would appear in a lot of type annotations, which was annoying, even for advanced users. So Ayaz Hafiz, shout out to Ayaz, came up with this design where we could, without sacrificing performance or really much of anything else, we could sort of get rid of that type variable, but that removed our ability to express certain things, which we concluded was kind of fine because these are like not things that people want to express. Like we couldn't really come up with any like realistic scenario where anyone would like miss losing that expressive power. But as a consequence of that, Now, because you still can express that in Elm, it's like a certain constraint where you say like, I want to, I'm trying to remember exactly what it was. It's like, I want a pattern match on these things, but it's not allowed to sort of grow or become like a bigger union. I don't remember exactly what it was, but it was something along the lines of like restricting it from possibly growing, which there's other ways you can do that in Roc, but now you can't do it with just tag unions. You'd have to like wrap it in an opaque type. Point is, in Elm, you already can do that. And that's like, in fact, the only mode. And in Roc, you used to be able to do that, but now you can't say that anymore without combining it with another language feature, which kind of seems fine. So that's an example of Roc being both more expressive and less expressive in some ways than Elm on the same language feature. The more obvious one, I guess, is Roc has a system called abilities. And so this is for ad hoc polymorphism. So we're talking about like traits in Rust are the closest analog to what abilities are in Roc. But Haskell type classes are a little bit further out because they have higher kinded types, which actually now you can do some higher kinded stuff with traits in Rust, but it wasn't true when we first developed abilities. But abilities are definitely an intentionally simpler and more minimal feature than either traits or type classes. You can't do as much with them, and that's very much by design. But a specific thing that this lets you do in terms of expressive power is you can define your own custom equals for a given type that you're making up. So if you make a custom hash map or something, you can define what equals means when equals gets used on that hash map. Whereas in Elm, you can't customize that. So that's kind of the main consequence of that. That's something that you can express in Roc, but not in Elm. There's one other very minor thing that gives us, which is that I assume this is going to happen in Elm in probably a different form eventually, but it is how we accomplish the goal of making it so that you can't compare functions for equality, and you get a compile error if you try to do that, because that's, without going on a huge tangent, not a good idea to have that return anything. It should just be an error if you try to compare two functions. And we talked through all the possible designs for that, and it definitely seems like compile time error is the best design. And separately from that, we also used it, and this is definitely an experiment, which so far has been working out fine. We chose to use it to also ban equality on floats. So if you try to do two floating point numbers, very small tangent, we have three fractional types. So 32-bit float, 64-bit float, and then decimal, which we shorthand to DEC, like DEC, short for decimal. So equals is allowed on DEC because it's a fixed point number and it's more precise than floats in terms of doing decimal addition and subtraction and other arithmetic operations. So like 0.1 plus 0.2 in almost every language will return not 0.3, but like, 0.3, like, I don't know, some long series of trailing numbers, because floats are base 2 rather than base 10. And so they get some imprecision when you do base 10 operations on them. But with decimal and Roc, that's not the case. It is totally precise for base 10 operations because it's just an integer under the hood. And, we just kind of shift the decimal point around. That also means it's slower than floats for a lot of operations. So floats are definitely a better choice for performance, but if you need that. But the main trade-off there is that like decimals, since they're not losing precision, they're either like it works or it didn't. We do think it's fine to compare them with equals. Whereas with floats, it's usually risky to do that. And it's generally a better choice to say, well, if I've got two floats in here, maybe I should compare them with like subtract them and see if the result is less than some very small number, depending on what your tolerance wants to be. I say that's still an experiment because although we've had it for a while now, people haven't been using Roc for things like games and whatnot. And I could see it maybe being annoying to people who are doing a lot more stuff with floats than the current set of use cases for what people are using the language for. So we'll see. It's a good example of the principle of if we're not sure, let's try the thing that hasn't been tried before, because it's a lot easier to fall back on the old behavior, the tried and true behavior that everybody's used to. Oh, that reminds me of another micro tangent. Another thing that was an experiment that didn't work out was I tried making it so that division always returned a result rather than a number, meaning that if you had division by 0, you would have to explicitly handle that possibility. It didn't work out. Basically, everybody ended up in practice just saying, let's just get rid of this and, with default 0, and it just became the sort of chore that everybody did to just like throw away the result and like default it to 0 or something like that, which is less good than having it crash on division by 0, which is what a lot of languages do. Like Python does that. So that's what we do now.
Yeah, I like to say, for example, that regarding the behavior of floats, it's also always easier to start with something restricted and then relax it than the opposite, right? So yeah, and I think it brings like an interesting question related to data structures. For example, like if you're going to implement a data structure like a dictionary or a map one of the ways you can implement it is that you need two properties, right? You need to be able to hash the thing that you're going to put in the map in the dictionary, and then being able to compare them. So would this mean in your case that I wouldn't be able to have a float as part of a dictionary map key depending on the implementation of that thing?
That's right. Yeah, that is one of the and we did talk about that. A somewhat related benefit of that is that you may be familiar with, like, if you put floats in sets. So another thing that I tried to do, which ended up concluding this is just a mistake, was I tried to get rid of not a number and infinity and negative infinity, and basically just like add checks for those and translate them into crashes and things like that, which I concluded was the wrong design because the whole reason you're using floats is for performance, and that's just going to hurt the performance if you try to do those things. So it's kind of like defeating the point of, having access to floats in the first place. And so given that you can have infinity and negative infinity and not a number, putting them in dictionaries and sets also has like another failure mode, which is that it really kind of breaks the semantics of those. Like you can put several not a numbers into a set and then you can never get them back out again because, or into a dictionary as the keys, because whenever the dictionary goes and asks the CPU, hey, are these two things equal? It says nope, always. Yeah, so not having them have equals also sort of addresses that case because, yeah, like as you sort of inferred, dictionaries in Roc are hash maps. The keys do have to have equality defined, which means that you cannot put floats as in the keys for dictionaries.
I wonder if you could, would it be possible for you to define something like a finite float 32? And then for those cases, you would add checks to the program that make sure that it's not a nan or infinity or something like that.
Yeah, so actually anyone can do that because we have abilities. So what you can do is you can make a new opaque type that's called, finite float or something like that, and then just define equals on finite float to be, normal, like subtract the two floats and see if it's zero or whatever you want to do with that. Or no, sorry, I guess you don't even need to do subtraction. You can also do like, see if one is less than the other one, and it's not less than and it's not greater than. Then it's equals by default. And I believe that LLVM will actually optimize that out to float equality. So I think you don't even have to sacrifice performance if you want to do that. But then that would give you the ability to do something like, when you construct one of these, then it will do the check right then to make sure that it's finite. Or, there's a lot of different ways you could do that.
Would that require wrapping the float, the underlying float? So like boxing it somehow, or it doesn't require it?
Wrapping, yes, but not boxing. So you would need to wrap it in what we call an opaque type, which is essentially, it's a zero cost wrapper that's just for the compiler, but It gets thrown away at runtime.
Really nice. And I have a question. It may be wrong, but if I check the docs, if I remember the docs, you can have lists that mix like integers and strings.
Yes.
Right. So how would that expand going with this idea that you can have like different types and how the operations? So would I be able to have a dictionary that stores both integer or string keys? Or would this not be defined because I can actually not compare them? How would that work with Roc?
So in the case of like, I want a list of things that has a mix of integers and strings, the way that you would do that is by making a tag union that says, I've got an integer, here's my integer, or I've got a string, here's my string. And so the way that you would compare them is basically you would need to do a pattern match on that tag union to check and see at runtime, do I have an integer, do I have a string? And then if I have an integer, compare the integers. If I have a string, compare the string. And the same thing would be true, in the list or in the dictionary case.
Okay. I think I get it. Is the dictionary implemented in Roc itself, or is that a native data structure?
Kind of both. So we have, it is built into the language. We have a built-in dictionary, but if you look at the implementation, it's just all Roc code. So you could totally implement your own from scratch if you wanted to.
So how would it work in this case? Because if we're talking about a hash map, like the thing that is comparing the thing, if it's comparing like the entry, the key that is stored, is deep within the hash map itself.
Right.
So how would I tell the hash map, like, hey, if you get an integer, that's what you compare with. Or if I get a string, that's what you compare with. Or that's handled with some other abstraction.
That's a great question. So at runtime, the tag union is going to be either it's the integer or it's the string, and then also it's some little extra bit of metadata, some very small, it's like probably 1 byte, that's like, is this an integer or is it a string? And in the source code, that looks like you have some actual like word there, but it gets compiled down to just 1 byte. Now, that's going to be what you pass in, and that's also what's going to be stored in the actual dictionary. So the first thing it's going to check when you're doing the equality comparison is, if you gave me a string or you gave me an integer, is the tag that you gave me that marks whether it's a string or an integer the same thing as what was stored in memory? So as an example, if you're like, give me one of these integer keys, all of the string keys are going to return false without even looking at the contents of them. It's just going to look at that one sort of tag byte to say like, which one is it? And then as soon as it sees that it's not the one you gave it, it's going to bail out and say that, it's false.
Ah, fantastic. So the tagging also literally becomes a tagging at runtime as well, that it would be...
Yeah, so tag unions are definitely, a runtime check.
Very nice. Yeah, thanks for explaining.
Yeah, sure.
I think we can move a little bit past types now. I think
Okay.
it was quite some time on types. You mentioned something called opportunistic mutation.
Yes.
And you also gave a presentation saying that Roc, while being a functional programming language, you could implement like quick sort in a way that would be as fast or even faster than some imperative languages.
Yes.
So can you tell us a little bit more about it? How is this possible? And so on.
Yeah, so the idea is fundamentally pretty simple. So there's 2 major styles of automatic memory management that people do at runtime. I guess I should say 3. So one way is what C++ and Rust do, which is essentially that they insert calls to like explicitly allocate this memory and then free this memory at this other point, kind of based on this static analysis of where things are. That has various trade-offs around like how reliable do you want the thing to be? What do you want the chances to be that it gets it wrong versus the complexity of the type system? Rust is more on the side of like, you have to model things in the type system very explicitly around lifetimes, but that means that you don't have to worry about it getting it wrong. C++ has different trade-offs. That's one camp. We're certainly not going to do that because of ergonomics/memory safety reasons. So the 2 much more commonly used strategies are either tracing garbage collection, which is what is the more popular of those 2, and automatic reference counting, which is most notably done by Swift and Python. Roc uses automatic memory management, and it specifically uses automatic reference counting as a way to implement that. One of the cool things about automatic reference counting is that you can know at any given point in time how many things are referencing this, at like right now at this exact moment. You don't get that with tracing garbage collection. You don't track that along the way, and then whenever you periodically run your trace to go detect what's sort of live and not, that's when you do that analysis. But with automatic reference counting, you always know it at any given moment. So the idea behind opportunistic mutation, which that's the term that I like to use for it, but I didn't come up with that. We actually found out about this from the people who make the Coca programming language, and they use the term functional but in place, or FBIP for short. I'm not personally a fan of that term just because I don't think that immutability is a purely functional thing. Like languages can have immutability and not be functional. So to me, like it's functional versus in place is a little bit of a false dichotomy. So I like to say opportunistic in place mutation, or just opportunistic mutation for short. So the idea behind this strategy is I have an API that looks like everything is functional. So a really simple example of this is we have a function called list.set, and it's like, give me a list, which is semantically immutable. And then I'm going to give you an element and an index, and I'm going to set the elements at that index and then give you back a new list that has that set. So the traditional way that this would be done in a lot of functional programming languages is node sharing. So you have like usually a linked list, and if I'm going to run this operation on it, it's going to give me back a bunch of the original nodes in that linked list, except one of them is going to be different. And I might need to, because the linked list is sort of like chained, I might actually need to give you back more nodes than just that one, because they need to point to the other ones that point to the new one. So that's node sharing. That's the traditional way of doing this. Clojure has a particularly fancy way of node sharing. They actually use some trees, or I guess like TRIE. I'm never sure how to pronounce that word. I've heard trie, I've heard tria, whatever. At any rate, it's a fancier persistent data structure, I think, which came out of Phil Bagwell's work, which Rich Hickey adapted for Clojure, if I remember right. And I think he wrote a paper on his persistent immutable data structures. Anyway, that has some interesting trade-offs when it comes to concurrency and being able to like express things across threads. But what we do is something that's much more focused on single-threaded performance, which is a Roc list. We're using the term list the way that Python uses it, which is to mean sort of a growable flat array of contiguous elements in memory, or like array list in Java would be another example of that. And essentially what we do is we say, okay, when we call list.set, what we're going to do is we're going to look at that thing and say, is the reference count exactly 1? If the reference count is exactly 1 at runtime, then we know that nobody else is looking at this in memory. So if we clone the whole thing, that's just going to be a waste of time because we're cloning it for nobody's benefit. Nobody else can see this thing. So instead what we do is say, well, look, the reference count is 1. We're just going to mutate it in place and then give you back the same list that you passed in. We just mutated it and you have no idea that it was the same one. You don't care. You're just like, I got back a new list that has that one element changed. If the reference count is more than 1, then we have to clone the entire list, make the change, and then give you back that cloned list so that everybody else who still has a reference to the original list doesn't see it mutated out from under them. That would break the semantics of the immutability. So that's what we mean by opportunistic in-place mutation. On top of that, we also have some additional analysis that lets us determine in a lot of cases at compile time that this is safe to do such that we don't even need to check the reference count at runtime. We're like, we know for sure it has to be 1 at this point. So we're not going to even bother checking it. We'll just jump straight to doing the mutation. That turned out to be relevant for getting the performance of quicksort to beat, I think it was Go needed that optimization. Without it, we were a little bit slower than Go, and with it, we were a little bit faster than Go on the quicksort benchmark. So that's the basic idea there.
So when are you unsure? Which language feature makes it so you're not sure about the ref counting? Is that like asynchronous operations?
You mean in terms of like the design of it, like whether it's good or not?
No, I mean, so usually you can know, right? Like, hey, I'm sure that the ref counting at this place is going to be 1, but there is something that makes you not sure and you have to check at runtime.
Got it.
So what could make it unsure?
Things like conditionals and loops. Like, so for example, I might have something that's being referenced by, I don't know, some other data structure, some other collection or something. And we're like going through a loop. And at some point in that loop, we remove, like get rid of the other one. And now that reference is gone. And so in a later iteration of the loop, it is 1, even though in an earlier iteration of the loop, it wasn't 1. So that can sort of minimize the quantity of checking that we have to do if sometimes it becomes 1 when it wasn't previously.
Nice. And how does the developer have control over this? So imagine that I want to implement my own quicksort or another sorting operation. Do I need to write like 2 definitions of the functions? Like, hey, this one is for when I know that this argument is mutable. This one is for when I know it isn't. Is that exposed at the language level in any way?
So currently it's not. And this is an area where I feel like the experimental nature of this is something where I just don't know what the right answer is going to be long term. I'm definitely reluctant to add explicit language features for exposing this or like letting you put constraints on that, because I think there could be some like ripple effects around that, where I definitely would not want to end up in a place where people make 2 versions of every API, one where it's like guaranteed to have, you know, a unique thing so it can do the in-place mutation, and one where it's not. And I also don't really like the idea of saying, well, you have to give this function, you know, a unique thing because that's like part of the type system now in this hypothetical world. Because then it's like, well, what are people going to do? I think it's going to go basically the way that sort of division thing went, where everyone's like, okay, so I just have to clone it before I pass it into this function. That's just this chore that I do. And you're going to end up with the same behavior that we have today. It's just that, you know, people are sort of annoyed by having to do that. I don't know that it would actually improve performance in practice. Having said that, definitely something that we want to try to look into is giving people tools for performance optimization so they can figure out more easily if there's a bunch of cloning happening because the reference counts are not 1, like where is that happening? Why is that happening? And today we don't really have any explicit tooling for that, but I think that is a promising direction to go in, where, you know, if your performance is fine, then like, okay, maybe you don't care. You're just like, yeah, everything's good. I don't need to mess with this. But if it's not fine, or maybe you're like, I know that I'm going to get much bigger data coming through here, and so I want to make sure that, you know, I'm not accidentally cloning things unnecessarily. Giving people some way to not have to like trial and error their way through that, I think would be definitely a good idea to explore. But we don't really know exactly what that should look like yet. We haven't really run into these types of problems very often in practice. We've seen a couple of like advent of code type problems where someone's like, hey, this is running a lot slower than I expect. And then someone, usually Brendan Hans Connect on Zulip, shout out to Brendan. He's done a bunch of stuff to make Roc run faster. He'll say, oh, I bet you're doing extra clones here, and, you know, try refactoring it to work this way, and then the performance gets much better. So giving people more tools so that they can figure that out more easily for themselves on their own, I think is a good idea.
Yeah, one of the reasons I ask is because as we start, like in the Elixir community, for example, start doing more data work, you start running into performance issues that you wouldn't run before.
Yeah.
And some of the things like sorting, like, yes, we can make sorting fast, but they are like known functional solutions for sorting that is going to behave like quite efficiently. But then you start running into things like median. You want to compute the median. Like a very easy way of doing that is that, well, you sort the list, you get whatever is in the middle, right?
Sure.
But if you have a large list, like the whole sorting is actually an expensive operation, especially if you're in a functional programming language where you don't have immutable sorting. And so we are trying to solve issues like that. And for example, I can't find like a good functional solution for the sorting problem.
Interesting.
So and in the case of like medium, for example, it's not really about mutating the data structure that you give as argument. It's really about while I am in this loop computing the median, I want to have something that I can mutate. Like it's not really about the input. It's like something intermediate for that computation that I want to make mutable, and it never escapes. And I think there are like some other programming languages, I may be saying wrong, like Flix, that they are like exploring things on this. Are like, hey, what if I can make some things mutable in this? That is also very interesting. My parenthesis here is that I think it's a very exciting new area of research. Everybody like exploring solutions to these problems and how we can enable opportunistic mutation. So for those who are interested in this, go check out Roc, Coca, Flix. And I think this is a good segue into the next question, which is, what would you say are like the biggest influences on Roc?
Quick note before we move on. So I believe Clojure has something called transients, which let you do sort of temporary mutation of things, where you're like, in this section, I'm going to allow mutation of this data structure. And then at the end, we're going to sort of seal it off again and make it immutable again, which I don't know if that approach is potentially addresses that, but anyway, worth looking into.
Yeah, do you think, I don't remember if the Clojure one actually guarantees for that thing won't escape in any way.
That I don't know. Yeah, I haven't personally used it. I've just heard of it. Potentially worth looking into. And I know Haskell has software transactional memory, but I also have not used that. I don't even know if that is useful for this. Anyway, okay, so you're asking about influences. So obviously Elm is the biggest influence, like Roc being a direct descendant of Elm. But beyond the obvious, so I would say there's a number of individual features that are definitely inspired from other languages. So the ability system is definitely inspired most directly by Rust traits, because it's sort of like a scaled down, even further version of that, which you could arguably say also means Haskell's type classes, because Haskell's type classes definitely influenced Rust traits. Also, maybe a less obvious one is from CoffeeScript, there's only one syntax for defining functions. That was how I got it. Like the first language I used in functional programming happened to be CoffeeScript, because it was in that multi-year window of time when CoffeeScript was really popular. And that happened to be when I learned functional programming and was doing front-end web development. And something that I really loved about CoffeeScript was that they only had one syntax for defining functions. Like anonymous functions and top-level functions had the same syntax. There was no sugar for that. And because of that, it really sort of reinforced for me, it's like, oh, functions are not special in this language. There isn't like a distinction between functions and methods, or like in Ruby, you have like blocks and procs and lambdas. And it was like, there's just the one primitive. And it's always the same, whether you decide to use it anonymously in the middle of a call, like to map or something, or you decide to define it at the top level. It doesn't matter. It's the same basic, simple thing. I love that. And so that was an intentional choice in Roc to make there be only one syntax for functions. And it's the same whether you're using them anonymously or naming them. So that's kind of a minor influence, but also from Golang. So Go influenced Elm format, for example, like having a built-in formatter with no configuration options, which I'm a big fan of. So we have Roc format, which works the same way. There's intentionally by design 0 ways to configure it. Another thing that we are it's in the design stages, I guess I should say, is package management. And I really like the design so far of how Go's version selection does, the minimum version selection design. It looks really appealing, and I haven't sort of hammered this out all the way yet, but it seems to be a really smart way of resolving version ranges in packages, which right now and today in Roc, we don't have a concept of version ranges. Everything's just got one version and you load it from a URL, but we're talking about wanting to add version ranges and more featureful package management. And definitely inspired by Go's approach there when it comes to version selection.
I'm curious about this one. Can you expand, or I can read about it later, but can you expand like how it would differ from something like, because I believe like Cargo and maybe other programming languages, they kind of adopted an algorithm that is kind of, everybody started using it for like dependency resolution. Is that the same thing, or is that something else?
I'm guessing you're talking about PubGrub? Is that the algorithm?
I believe yes.
Okay.
Yeah.
Okay, so I can talk about this based on my familiarity with Elm's package management resolution algorithm, which is the one that I'm most familiar with in practice. I don't know exactly how Cargo's works. I mean, I use Cargo all the time, but I'm not that familiar with like what they're doing under the hood. So the way Elm works is I can say, okay, my package depends on, let's say, I don't know, this like JSON, for example. I want JSON. I depend on JSON, and I can specify a version range saying my version of JSON needs to be at least, let's say, 1.2 and less than, but not equal to 2.0. So I'm saying like, I don't know what version 2.0 is going to look like, but I assume I'm compatible with any 1.x version starting with 1.2 because I'm using some feature in 1.2. And so if you give me 1.1, I won't be able to, compile up to, but not including 2.0 because I don't know what 2.0 is going to be. It's going to be a breaking change. And who knows if I support that. Okay, so that's the basic idea of Elm's solver. Then let's say I have two different dependencies and each of them depends on, in this world, I'm a package. So I'm a package that depends on JSON. And now let's zoom out a little bit and say I'm not a package. I'm now an Elm application. And I depend on two different packages, one of which is the one I just mentioned that depends on JSON, at least 1.2 and less than 2.0. And another one which depends on JSON, let's say it's a little bit earlier on, it depends on JSON 1.1 and less than 2.0. So to solve that, Elm can say, okay, well, I can use any version of JSON that's at least 1.2 and less than 2.0. Now, what Elm does at that point is if I have a brand new Elm project, like I just ran Elm in it and I'm like install both of these two dependencies, what Elm is going to do is what most languages will do is they'll say, oh, I see that there's a JSON version 1.5 out. That's the latest version that happens to be out right now. I'm going to give you that one because it's presumably better than, 1.2 is the minimum that you need for those two. But I'm going to give you 1.5 because it's presumably got some better stuff going on. Maybe it's faster, who knows, even though your dependencies aren't using it. And then I'm going to pin that. So I'm going to write down in your application's elm.json file, you're on 1.5, which is important. This is like the equivalent of many languages have lock files to do this, but basically so that, let's say 1.6 comes out and some other person on my team is, installing the thing. We don't want them to get 1.6 because now we might have, a bug on one, but not on the other or something like that. It might get confusing. So you want to make sure that once you do that, you pin it. Okay. That's how most package managers that I have used these days work, including Cargo. Minimum version selection says you're getting 1.2. You're not getting 1.5. I don't care what's out. I'm just looking at the minimum version that will satisfy all my dependencies, and that's what you're always getting. So this has a couple of really interesting properties. So an obvious downside of this is that let's say that there was a bug fix or performance improvement that came out since my dependencies updated. I'm not getting that. I'm just getting the minimum thing that we know works with them. I'm getting 1.2. So I'm missing out on that. But I'm getting a couple of really cool benefits. So one is I don't need a lock file anymore. There's no need for that because this is just completely deterministic. If I just tell you, here are my dependencies, it's like, cool, 100% of the time, I will solve them to the same exact set of transitive dependencies. No need for a lock file ever. That's cool. I like that. Second thing is you don't have the risk of different people who are like installing the same thing at different times. If they don't have a lock file, getting a different experience. So an example of this would be like tutorials on the internet. They say, run this in it, and then install this, run install that. Different people might get a different experience if other intermediate things have been released. There might be a bug introduced or something like that. Or maybe the strings in it, like the error messages or something changed. And now they're like, wait, the tutorial said this, but so there's like more consistency. Another argument that I think is interesting that comes out of the Go team is you're not automatically opting into things that could not have possibly been tested by the people who released those packages. So whoever released the package that depended on JSON 1.2, they tested it with 1.2. Like they know it works with 1.2. The other package that depended on 1.1, they probably didn't. But at least you now have one of your packages has 1.2 tested. And then if 1.5 comes out, none of your dependencies were tested on that for sure. So that's the basic idea. And it's a really simple idea. They talk in there's a write-up about it. You can check it out online about like the design and some of the trade-offs they're considering. There's a lot of time spent on how fast this solver can work and how it's obviously very simple, but also I guess it has some nice performance properties. I was kind of surprised by that because I don't think of solving your package dependencies as something that's like a significant part of performance kind of ever, but they seem to be disproportionately concerned with that, I guess, relative to how concerned I would be with that. Nevertheless, that is, I guess, also a benefit is that it runs fast. But at any rate, so I thought that was really interesting, and it's something that I'm interested in using with Roc. Also worth noting that, of course, if you want like 1.5, you can just put that in your application and say like, well, I want 1.5. It's like, cool, you're getting 1.5 because now that's the minimum one that satisfies all the dependencies.
Yeah, no, that's very interesting to hear. And dependency resolution can actually take quite a lot of time. So
really? Okay. That's the first I've heard of that.
And depending on how flexible you make the requirements as well, that's going to affect directly. So I think PubGrub like rejects some particular requirements because of the complexity that they add to the resolution. And that's something that we learned in Elixir the hard way, because we were like, oh, okay, we'll just allow like these expression of requirements like and, or, and so on.
Yeah.
And then it turns out that in some like cases that could become really, really slow. And when we started the package manager for Elixir, it was before PubGrub. So there were some ideas, some optimizations where you have everybody working on the same problem. We're like, oh, we can do this, right?
Yeah.
So we would run into those cases where, oh, this is actually like, it's treated like a pathological case that is super slow.
Oh, wow.
And then, yeah, so I think it's interesting that they are thinking about that from this perspective. I would still like, because something else that is going to be is you have to think a lot about is also like the indexing, how you're going to distribute the index. You cannot have like a global index, how you're going to split then the index, distribute that and share updates. I don't know, for example, like with Rust, every time I use Rust and it wants to update the index, I'm like, why? I don't know if it's because like there are so many packages that it takes quite some time, or if there are some decisions with the indexes. But that also can be like a very expensive part of the whole process. And I think like you would probably, even if the resolution is super fast, I would probably still cache it locally anyway, and cache the indexes and cache everything, because especially if you want to run it like before every command, like how do you know if you need to check if the dependencies have been resolved again? Like maybe it depends on if you change like your TOML file. How do you describe Roc projects? Is it a TOML file? Is it?
It's actually baked into the .roc file. We don't have a separate like anything for those.
And that's like Roc syntax?
Yeah.
Nice. Okay.
So one of the design goals there, and like part of the reason for that is one of the long tail of use cases that I like to use Roc for is scripting. Like I give you a script without going into a huge tangent on platforms, which, you know, maybe we should. But without doing that at this moment, one of the things that you can use Roc for is to make it so you can, somebody gives you a script to run from the internet, you look at the source file, and rather than having to audit the entire thing, all of its dependencies, etc., you can just look at one line and be like, oh, this is using the safe scripting package. I know that no matter what this code is, it is not possible for it to do anything other than prompt me whenever it wants to like read from certain directories or write to certain directories. Like it's going to be as sandboxed and safe as a web browser. And I only have to audit one line of the entire source code to do that. So I really would like it to be usable for that. But another goal is like a lot of times I've downloaded packages from the internet, like Python packages, for example. And in addition to being totally unsafe, and it's like I'm just kind of crossing my fingers that it's not going to mess up my system, there's also the fact that in a lot of cases it will fail because there's some dependency that it's missing. So by design, you can have just a single .roc file that does describe, okay, I have multiple dependencies that need to get downloaded right there in the file. And also, we don't even like pollute the directory that you're running it in. All the things that get downloaded get put into like a global cache in your home directory in the like .cached or yeah. Anyway, so that's the end of small tangent on how those things are specified. So basically, another cool thing about this like minimum version selection, which you should be able to have with a lock file as well, I would argue, but basically it's like you never need the index locally. I mean, if you want, you can cache some of it just for like future solving needs, but it's like, well, let's say I'm doing a build. What possibly could change about my build based on getting an updated index? It's like, we already solved all these to the minimum version. If there are new versions, I don't care. We're not solving to them anyway. There's no chance we would solve to them. So the only possible reason you could want to go to the index is if maybe there's like a security advisory or something like that, which I am not convinced is something that should run on every build as opposed to being like a separate thing in CI, like a, Dependabot style type of thing. So my current thinking, and again, this is like, we're at the stage of this where it's like, I have a work in progress design document. There's like 0 lines of code written for the actual implementation of this. But my thinking is like, yeah, we just don't ever check the index when you build. You can build completely offline and there's no downside compared to if you were completely online because we don't need that info for anything.
That's fantastic. Really interesting. And so you talk about like the minimum version related to dependencies.
Yeah.
But also in my project specification, if I say 1.5, that's only getting 1.5. It's not getting 1.6, 1.7 or anything, regardless of when I install it.
Yeah. So my plan is to have that be a little bit different depending on if it's a package versus if it's an application. So this distinction also exists in Elm. So in Elm, like if you're building an application, your elm.json is only allowed to specify exact version numbers, which is kind of how it implements like a lock file. Like you say, I depend on 1.5. It's like you're getting exactly 1.5. And also if you say 1.5 and one of your dependencies depends on a version that's incompatible with that, you'll just get a build error saying like, hey, you can't use 1.5 if you want to use this dependency. You got to use a different version. Whereas in Roc's case, my plan is to not do the sort of explicit, like write out the version range that Elm has, but rather to say, if I say 1.5, I always just say one number. And the one number, if I'm an application, means I want exactly this number. And if I'm a package, I'm saying I need at least this number and less than the next major version. And basically this is another thing that I believe Go does, but I think maybe Rust might also do it. I'm actually not 100% sure about either of those. But the idea that I have in mind is to make it so that different major versions of packages are treated as essentially completely different artifacts. Like they're not even the same package anymore. It's as if you published it with a 2 at the end of your name. It's like a totally different separate thing now. And as a very small aside, we already have a design because I've been thinking about this for a long time. It's already possible to import multiple versions of the same package and have them coexist and like namespace them differently, because that's always something that I've wanted in like every language I've used, where it's like, I'm trying to do an incremental upgrade. I really want to just have just this part of my code base use the new version without having the rest of my code base have to upgrade yet. And that's always something I've wanted. So that's been designed from the get-go. But yeah, so basically it's like if you say 1.5 and you're a package, that means I am claiming to be compatible with at least 1.5 and it's acceptable to give me 1.6 or 1.7, even though I don't necessarily know what those are yet. And meanwhile, if I'm an application, I say 1.5, it means I want exactly 1.5 and give me an error if one of my dependencies needs 1.6.
Fantastic. Yeah, and you did mention platforms. I actually had questions about platforms here, but we are like over 1 hour. So I think let's leave something for people listening to the show to go and explore. So go to the Roc website. The new version of the website it's great. Congrats on the launch. I think it happened like 2 or 3 weeks ago.
Yeah.
And folks should definitely check it out. So for just to start wrapping up, I want to do like couple very quick questions, not so much in depth. So I've heard from you that this is no longer a solo effort. So who is working? How many people are working on Roc? Who is the team?
That's a great question. So, I mean, it's me, and then there are a couple of other people that are getting paid by their employers to work on Roc some of the time, like not 100%. Nobody, including me, is like spending their entire workday on Roc stuff. So the other people who are getting paid in part to do it are Volkert de Vries, who has the most commits on the repo now. I'm in second place now, even though when I started, it was all me. And the other one is Ayaz Hafiz. So Volkert works at, I'm always going to attempt to pronounce this correctly, but it's Dutch, so I'm going to do my best. It's called Tweede Golf, I believe. Dutch people, sorry. And then Ayaz works at rwx.com. And basically, both of them are like investing in Roc, like with a percentage of like having Ayaz and Volkert work on Roc stuff, which has been amazing. And I really appreciate both of them for sponsoring in that way. Also, shout out, we have a couple other sponsors, some of which are pretty recent, that are just kind of doing a direct financial donation, which also really, really appreciative. They're on the homepage. So yeah, basically, I'm at vendor, vendr.com. So we're the ones that are sort of getting paid. I'm working on, like we've been setting up donations and we want to start paying Anton to work through the foundation. Anton has been like absolutely essential to basically doing all of the like hard behind the scenes stuff that honestly, like most people are like, I don't want to do that. Like Anton just does all that stuff, like all the CI setup and like builds breaking and like making sure it works cross-platform and like all the release management and like beginners have questions and he like, responds patiently and then like writes up issues and like all this stuff that like, I'm like building LLVM from source so we can like get that into the byte, like all these things. I'm like, I never want to do all of this stuff that's really important, but like not highly visible. It's like, he's been fantastic. That's honestly the main reason I've been like raising donations is I would really like to be able to pay Anton like a full-time salary to just do all of the amazing stuff that he's doing for Roc. So besides that, we also have a bunch of people who are volunteers. So Brendan Hansknecht has done, I mentioned him earlier, he's done a bunch of like miscellaneous stuff on Roc, like performance stuff, data structures. He's the reason that like Roc Glue works the way that it does. He's also made a bunch of like really cool examples and like larger like implementations of Roc applications that have like found a bunch of bugs in the compiler and stuff. Brian Carroll is like the reason that we have any WebAssembly support to speak of in Roc, rather than the trivial stuff that we had before. He made like the REPL that's on the homepage. He's been working on Roc interop with C++. Josh Warner did a bunch on the parser. That's been really cool. Without going like on and on and on, like I don't want to like, just rattle off all the names, but one more name I have to mention is Luke Boswell, he's been organizing the monthly like online Roc meetup. He's also written packages and a bunch of like platforms. Really, really appreciate all of their stuff. There are too many names to name of like people who have done smaller and smaller like things as you go down the contributors list. But yeah, I would say those people that I just mentioned are sort of like the most active regular contributors, except for time constraints, like leave out anybody else. It's just that like those are the people who have sort of been the most active in the community.
Nice. So the community is really growing, and you probably already went through a couple moments. I still remember like when other people started like investing really in Elixir as with their time, or sometimes companies, it was always so reassuring. And it seems you have gone through that a couple times already. So yeah, very exciting.
Yeah. Yeah, it's been cool to think back, like back when it was just me and nothing worked. Like it was a horrible language back then. It was just full of bugs. And like, but I still remember I was at the Phoenix airport. For some reason, I was like on a vacation with my wife, and I was like sitting in the terminal waiting for our flight. And I had just gotten a little like proof of concept interpreter working, and I put in like 1 + 1, and it was like 2. And I was like, it's a real programming language. I'm so excited. She's like, what are you so excited about? I was like, look at this. And she's like, 1 + 1 is 2. Like, what's the big deal? I was like, you don't understand. This is so cool. And yeah, to have gone from that to something that's like actually a real programming language that's like really genuinely useful and has all these really nice properties has been absolutely amazing, and 100% would not have happened except for all of these amazing contributors. So really, really appreciative of all of them.
And last question. So for those who made it into the end of the show and they want to learn more about Roc, play with it, where they should go, if they want to go back to Advent of Code and start doing it with Roc, there's probably still time. And what else can they do?
I mean, the main thing I would say is come join us on Zulip. Zulip chat is like the best place to get help as a beginner if you have like questions or you're trying to get into the language, anything. Like there's lots of us on there all the time. If you go to roc-lang, so roc-lang.org, there's a community link up at the top, and that'll take you to Zulip.
All right. I believe that's all for today. Thanks, Richard, coming to the show. And yeah, good holidays, New Year for everybody. If that's the last one of the season.
It is.
And yeah, perfect. And until next time.
Thanks so much.
Hey, this is Yair Flicker, president of SmartLogic, the company that brings you this podcast. SmartLogic is a consulting company that helps our clients accelerate the pace of their product development. We build custom software applications for our clients, typically using Phoenix and Elixir, Rails, React, and Flutter for mobile app development. We're always happy to get acquainted, even if there isn't an immediate need or opportunity. And of course, referrals are always greatly appreciated. Please email contact@smartlogic.io to chat. Thanks, and have a great day.